My name is Matthias Henzler. I'm working as a research institute at LZH for 3 years now, mainly in the topic of large format 3D printing. The Laser Zentrum Hannover is a non-profit research organization for laser and non-laser technologies. We are working on process development and working close together with industry and smaller companies so that they can benefit from our research and we can benefit from their technologies. 3D printing at LZH started with the founding of LZH in 1986. The first ideas of 3D printing was laser deposition welding, which later can be seen as the first 3D printing technologies. The entry point for polymer 3D printing were mostly desktop 3D printers which have a pretty small build volume, and we saw that for the internal applications these build volumes didn't last, so we needed to print bigger parts. And also our industry partners were more interested in using bigger parts as well.
I'm Joshua McCauley. I'm a researcher in the Optical Components department. I'm working with measuring the absorption of different optical samples. This in practice means that I irradiate them with a laser and then measure very accurately how they warm up and then how they cool down once the laser is turned off. This is the bottom half of the chamber. There are two other components which are still to be printed. Essentially we have this again repeated, which will come on top as sort of a roof, and then we have a section in the middle which is where we can where the laser beam will be going, and then we can swap that in and out depending on what sort of optics we've got in there, what angle we need to have the laser beam coming out of, because at the moment if we have a chamber, we have one hole for the laser beam going in, we have another hole where it comes out. And having holes in a chamber is a problem because it leads to convection and temperature chambers. So we can basically take this and just hot swap the pieces depending on what we want to actually measure. The key component with measuring the absorption is that we need to have a very, very temperature stable environment. We do this conventionally by making a chamber that's usually made out of aluminium, but the advantage with 3D printing is that we can move away from these sort of conventional restrictions, particularly the aluminium components, and make more unusual forms like this one here, which minimizes the surface area, and this hopefully reducing the impact from the environment in the lab. One of the big advantages is that we have a lot more flexibility in the form. It's not something which is easy to produce if we were using our standard construction procedures. It also gives us a lot more flexibility in terms of trying new things which would have been cost prohibitive before. We can just print, and I mean it's a lot cheaper than getting an entire chamber constructed. So those are the big advantages, that we can try things that we wouldn't have been able to try before, and we can afford to try things that we couldn't afford to try before.
We had two requirements that the printer has to be capable of. Firstly, an enclosed build chamber, and also the possibility of printing two materials in the same process. As a publicly founded research organization, we had to do a procurement process, so we ended up with BigRep machines. I think the VIIO really does precise parts. The overall dimensional accuracy of the printer is really precise. One-click print start. Instead of setting up the printer, setting up the temperatures before waiting for the temperatures to be reached, having preheat functions and print start by just one click is really nice to have. So you could focus on other things while the printer is warming up. Reliability of the system improved greatly because there are a lot of sensors in it. And if something went wrong in the printing process, the machine knows what it is doing and can stop it or can improve the flow. It's really a less stressful printing experience because you can rely on the results that the machine will be finished the parts at the end.